Hi, my name is Christina Mason, and along with Max von Duijn and Peter van der Putten as advisors, we developed 3 agent-based models of social influence, which take into account social identity and uncertainty as variables, and are based on the information exchange platform of Facebook. Our paper is entitled Identity and Uncertainty in Social Influence, an agent-based approach, and you can find it in the conference Proceedings. So the motivation for the study came from the urgency of researching information disorders so that we can develop counter strategies and recommend preventative measures. So part of this work is to better understand why people believe what they believe generally. But I became interested in the social identity aspect of attitude formation psychology because of a personal observation that not only did my identity inform who I was friends with, and therefore the information I'm exposed to, but also who is able to influence me. So this is the process of social influence. Um, Attitudes do not exist in a vacuum, and as social animals, social influence is a very powerful force in shaping our attitudes. And attitude and opinion are used interchangeably in this presentation and also in the literature. So very simply, social influence is when people change their opinion as a result of a social interaction. So what do you do when you're confronted with a different opinion? You either keep your opinion, don't adjust, or you adopt the other person's opinion, or you move towards their opinion by some measure. So in the study, we take into account social identity, which is the set of categories that you identify with. So these can be demographic or cultural, and they inform the kind of group memberships that you have. So they inform your in-group and out-group relationships, which is important because studies have shown that your in-group is far more influential on you than your perceived out-group members. And attitude certainty is just the subjective confidence with which a person holds a particular attitude. So we made 3 models. One was on social identity, the second focused on certainty, and the third was just a combination of those 2. So in existing models of social influence, we're talking about opinion dynamics. And so each agent will have a continuous opinion ranging between 2 numbers, often 0 and 1, and at the beginning, these opinions are uniformly randomly distributed. So over the course of agent interactions, multiple agent interactions, until the system comes to an equilibrium, you're trying to see what is the final distribution from this initial uniform and random distribution. So there are 3 possible outcomes. You can have a consensus formation, which is where every person shares an agreement on one opinion. On the other end, you can have bipolarization, which is 2 different opinions, often at extremes. And then the third is opinion clustering or opinion diversity. So what happens when you have a network where every agent is connected and every agent is able to influence each other? That system will always go to consensus. And so this is known as the Abelson diversity problem, which states that social influence will always lead to consensus unless there are perfectly separate agents who enact 0 influence on one another. So there are solutions in modeling. One of them is the bound of confidence, which simply says that if an agent's opinion is far enough away from another agent outside of its so-called bound of confidence, it is no longer able to influence the other agent. So consensus in itself isn't a problem in certain communities where everyone has a shared goal, where they're looking for the truth. For example, in scientific communities, when you share evidence and people influence each other, consensus isn't that abnormal. However, this is a problem for us because obviously the opinion distribution on Facebook is not consensus. So the implications of this for social media is that in terms of identity and uncertainty, people will defer to their in-group members under conditions of uncertainty. And especially in high information spaces, this becomes a heuristic, a time saver. Instead of you becoming an expert on every topic you could form an opinion, you defer to the opinions of those who you trust. So we were wondering if these factors contribute to the development of polarization or extremism in this context, and therefore create the kind of conditions where misinformation can be spread. And so we hypothesized that conditions of uncertainty would contribute to polarization or extremism in networks formed by social identity. So our three models have a population of 100 agents. They're uniformly distributed, as mentioned, at initialization. And an agent is chosen at random to broadcast. So this is to sort of mimic Facebook. And then all agents are exposed to this message, which is sort of even less biased in some ways than Facebook. So everyone gets all of the messages. And it's important to note that all agents have the same cognitive motivations and makeup. So no agent is inherently more influential or more able to be influenced. They all have the same programming. So influence works by this equation. For more information on these equations, you can refer to the proceedings. But it's but the change in an agent's attitude, delta x, is the original attitude plus the difference between the influencing agent and that agent's attitude times some factor ku. So in our models, ku is this equation down here, and it takes into account both agents' attitudes and their uncertainties. And this equation simply takes into account this distancing effect, which is consistent with the literature on attitude formation, including social judgment theory. And it just says that if the difference between two attitudes are large enough, the ability to influence decreases, and it is also related to the certainty of the agent being influenced on their original opinion. So in the interest of time, I'm going to just present to you the results of Model 3, but Model 3 takes into account the design of Models 1 and 2. If you want more information about those models, you can also refer to the paper. So every agent has an identity repertoire. So this is our set of dimensions. You can think of them as gender or race. And in these dimensions, they have a category, so how you identify within that dimension. And you can see from graph 1 here on the left that clustering can occur in the system developed by social identity as long as the average in-group is small enough, and that is dependent on the amount of similarities an agent requires in order to consider someone else their in-group. Otherwise, the system will collapse to consensus. And then the design, the algorithm that we designed in terms of certainty, we wanted it to reflect the literature on certainty, which says that agents with lower certainty are more vulnerable to influence, and then group consensus increases certainty. So you can see on the right here that the more clusters and therefore the more information in the system, the less certain the agents are on average. So the results of Model 3 were that it was a moderate system. And extremism and polarization did not result from the system itself, unless there were already extremists in the beginning. So the final standard deviation decreased, meaning that the system itself, opinions all sort of coalesce towards a moderate opinion while maintaining opinion clusters. So our hypothesis was not supported by the simulation. However, the third model did remedy the limitations of the first two models. So in the first model, all of the similarity threshold, which is how open agents are to the influence of other agents, had to be exactly the same. And in the second model, the bound of confidence, how far away an agent would have to be from them in order to still be influenced, also could not be randomized. So we were able to randomize those with this model, which created a heterogeneous population. And that is desirable in agent-based models because obviously humans are not homogeneous. And it legitimizes the design concept to the extent that if you add more layers to what influences these agents, or how these agents behave, you get more complex agents, and you are able to have more complex results. So in conclusion, the simulation was moderating. So identity and uncertainty, as far as we can tell from this design, are not the source of extremism and polarization. So this suggests, in terms of Facebook, that allowing for open influence between agents is a safeguard against extremism. So more information diversity, the more information that you expose people to will be potentially moderating in the system overall. So in future work, well, we always have to take into account that these are models. So in this case, people don't enter Facebook with a random distribution of opinions. They come in with lots of reasons to have the beliefs that they do. So these models are very limited in how they describe behavior, and we need to consider many more factors. But it's important to consider that you can create extremism on the basis, or you could potentially create the conditions for extremism with agents who all have identical cognitive makeups. So that's to say that you're not inserting a special agent. And a lot of these previous models have quote-unquote extremists who have different motivations, different faculties. So to suggest that there's nothing irrational about being an extremist. And importantly, finally, to compare to empirical data. So this is to say that to take empirical data, final distributions, or distributions that we know are true, and work backward from there, because that will then lend credence to the veracity of the design of the model in the first place. So that's the presentation, and I want to thank you for your time. And do you have any questions?